Welcome, developers and architects. Let's get started on mastering the powerful combination of the Claude API and the Model Context Protocol. Welcome, everyone. Today we are diving into a game-changing combination for AI developers, the Claude API and the Model Context Protocol, or MCP. Let's look at the first bullet. The Claude API is your gateway to integrating Anthropic's powerful models into your own applications. But an AI is isolated, it only knows its training data. That is where MCP comes in. As you see in bullet 2, MCP is an open standard that connects Claude to external tools and data sources. Why do we need this? Because writing custom integration code for every service like Jira, GitHub, or your internal database is tedious and hard to maintain. How we solve this is by combining the Claude API's native tool use capabilities with pre-built MCP servers. By the end of this session, we will deep dive into how you can transform Claude from a simple chatbot into a highly capable, autonomous agent. Take a look at this architecture flow on the screen. On the left, we have the Claude API, which is where your application lives and makes requests. When Claude needs external information, it sends a tool request to the MCP client. Notice the bidirectional arrow connecting the client to the MCP server. This is the magic of MCP standard, transport agnostic protocol handling all the complex communication. The MCP server on the right then talks directly to your external data or APIs. Instead of you writing custom code connecting the API to every single database, the MCP server acts as a universal adapter. Let's break down the Claude API basics. To talk to Claude, we use the client.messages.create method. It is the heart of the API. As shown in the basics bullet, you must pass a model name, a token limit, and a messages array. How do we keep context? The API is completely stateless, meaning it forgets past turns. You have to pass the entire conversation history, both user and assistant messages, every time you make a request. When do you need custom behavior? That is when you use system prompts to establish rules and personas before the conversation even begins. Look at the sample code provided. We instantiate the client, specify the sonnet model, cap our tokens to 1000, and pass in our user message. It's clean, simple, and gives you total control over the generation process. This sequence diagram illustrates the stateless nature of the Claude API. First, your application sends the complete message array and parameters to the API. Next, the API tokenizes the input and processes the prompt. Step 3 shows the API, returning the generated text back to your app. Crucially, look at step 4. Your application must append this new response to its local history. Because Claude doesn't remember previous requests, you must manage this conversation loop yourself, feeding the updated history back into step 1 for the next turn. Moving on to tool use. What is it? Tool use is how Claude reaches out to the real world. Why do we need it? Because language models are just text predictors. They can't natively query your database or check the weather. How do we enable this? By passing a JSON schema in the API request that describes your tool's name, purpose, and required inputs. The deep dive here is critical. When Claude decides to use a tool, it halts text generation and returns a stop reason of tool use. It doesn't run the code. Your application must detect this, execute the local function, and then as the final bullet notes, send the output back to Claude wrapped in a tool result block. This creates a multi-turn conversation loop where Claude acts as the brain and your code acts as the hands. Follow this state diagram to master the tool use loop. We start by sending our prompt and tool schemas to the API. Claude makes a decision. If it has all the info it needs, it outputs text with a stop reason of end turn. But if it needs data, it outputs a tool use stop reason. Your application intercepts this, extracts the arguments, and executes the local tool. Once you have the result, you inject it into a new API request and complete the loop. This cycle repeats until Claude has everything it needs to generate a final answer. Now let's introduce the MCP revolution. What does MCP actually do? It removes the massive engineering burden of writing custom tool schemas and implementation code. Why is this a big deal? Imagine writing custom tool functions for every single endpoint in the GitHub API. It is completely unmaintainable. The basics: MCP packages hundreds of pre-built tools into reusable servers. When should you use it? Anytime you want to connect Claude to complex, extensive platforms like Jira, Postgres, or Slack. Instead of authoring tools, you leverage existing MCP servers. How do you integrate it? You simply connect an MCP client to an MCP server, and instantly, Claude gains access to all the tools provided by that server. It shifts the integration complexity away from your application code. This flowchart contrasts the old way with the MCP way. On the top path, the developer chooses the hard way, manually writing custom tools for an API, leading to a high-maintenance nightmare. On the bottom path, the developer uses the MCP way, simply installing one MCP server. That single installation instantly unlocks a suite of pre-built, standardized tools, resulting in zero maintenance for the developer. MCP is all about efficiency and standardization. Let's explore the architecture of MCP. It fundamentally relies on a client-server model. The MCP client lives in your application and acts as the bridge to the MCP server, which hosts the actual integrations. Let's dive deep. The communication is transport agnostic. This means your client and server can communicate over standard input, output locally, or via HTTP and WebSockets remotely. How does the interaction start? Your client sends a list tools request to the server, and the server replies with a list tools result containing all available schemas. You pass these directly to the Claude API. When Claude decides to act, your MCP client sends a call tool request to the server, which executes the action and returns the result. It is a brilliant separation of concerns. Let's walk through this sequence diagram to see the full MCP lifecycle. First, your MCP client asks the MCP server for available tools. The server responds with the tool list. Your client then forwards these tools to Claude via the API. Claude analyzes the user's prompt and returns a tool use block. Your client automatically translates this into a call tool request and sends it to the MCP server. The server does the heavy lifting, talks to the external API, and returns the result. Finally, your client passes that result back to Claude to generate the final, informed response. MCP servers aren't just about tools. They provide three distinct core components. What are they? Tools, resources, and prompts. First, tools. Tools are designed for actions like executing a database query or posting a Slack message. Second, resources. Resources expose data directly to your client. Think of database schemas or internal documentation. Third, prompts are pre-built, expertly crafted message templates that users can leverage for better results. The deep dive here is on resources. Resources use a URI system like docs//filename. This allows your client application to fetch essential context and inject it into Claude's prompt immediately, completely bypassing the need for a costly LLM tool call. It is highly efficient for context management. This diagram neatly categorizes the three pillars of an MCP server. The MCP server branches out into tools, resources, and prompts. Following the top branch, tools map to real-world actions, like updating a database. The middle branch, resources, provides vital data context, such as reading API specifications or fetching file contents directly. The bottom branch shows prompts, which are ready-to-use templates, such as an optimized code review prompt. By separating actions, context, and templates, MCP servers provide a complete, well-rounded toolkit for your AI agents. Let's wrap up with a powerful real-world use case, an automated issue triage agent. How do we build this? We simply connect a GitHub MCP server and a linear MCP server to our Claude API client. When a user reports a bug, Claude autonomously uses the GitHub MCP to fetch the relevant repository data and investigate the issue. Once the code is analyzed, Claude invokes a tool from the linear MCP server to create a highly detailed, formatted engineering ticket. Why is this revolutionary? You wrote absolutely zero custom integration code for GitHub or Linear. The MCP servers provided the tools, and the Claude API provided the intelligence to orchestrate the workflow seamlessly. Thank you for joining. Please like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. In our final diagram, we visualize this real-world triage workflow. A user reports a bug, which enters our Claude API and MCP client application. Claude realizes it needs code context, so it branches to the GitHub MCP server to fetch the files. After receiving and analyzing the code, Claude takes the next step, branching to the linear MCP server to create an actionable ticket. The ticket is logged, and the engineering team is notified. This beautifully illustrates how the Claude API, paired with MCP, orchestrates complex, multi-system workflows autonomously.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.